Hi everyone, my name is Nikhat and I'm going to explain the project LSB Image Steganography. So here we are going to achieve steganography with the help of an image, and we are going to perform it at the LSB of the image. Hence the name of the project is LSB Image Steganography. So here in this project we are going to hide the information inside a BMP image, and then we are going to decode the information. So next we will see encryption and decryption. So before understanding steganography, let us understand what is encryption and what is decryption. So encryption is nothing but converting the readable data into an unreadable data where a third person do not understand that we have converted the data is called as encryption, whereas decryption is converting the unreadable data back into readable form is called as decryption. So here we will be using some algorithms to encrypt and decrypt the data. So here we will see the flow of how this encryption and decryption happens. So first we will be having this readable data. We will give this data to an encryption algorithm. So today we have n number of encryption algorithm available. So based on a convenience, we can choose whichever encryption algorithm we want to use. So whenever we give this data to an encryption algorithm, the data will be encrypted. So after giving the data to the encryption algorithm, the data will get encrypted. So here we'll be having this key. The transmitter and the receiver both will have the key. So the transmitter will use this key to convert the data, that is to convert the readable data into an unreadable data, whereas the receiver will use this key to convert the unreadable data back into the readable data. So once we give the data to the encryption algorithm, the data will be encrypted. This encrypted data will be given to a receiver. The receiver will receive the encrypted data. So again the receiver will be having this key, and the receiver will make use of this key and the decryption algorithm. So based on this decryption algorithm and with the help of this key, the receiver will convert the data back into readable form. So again once after conversion, we are going to get the original data back. So here we are just converting the data into unreadable form, and we are converting the unreadable data into a readable form. So this is about encryption and decryption. So next we have is steganography. Steganography is the technique of hiding data within an ordinary non-secret file or message to avoid detection. So here in steganography, we are going to conceal the information inside some file. So the information can be any text, audio, video. So we are going to conceal that information into another file. With steganography, we can hide secret credentials, detect data forgery, message passing. So this steganography can be used to transfer or transmit confidential information. The next is steganography is used in military, intelligence agencies, online elections, internet banking, medical imaging, and so on. So these are the applications where we can use steganography. Next is steganography can be done with the help of physical, prints and pins, puzzles, and digital. So here in our project we are going to use digital steganography. Steganography is a combination of encoding and decoding. Whatever you are seeing at the LHS is the encoding part, and whatever you are seeing at the RHS is the decoding part. Suppose I have a text file, that is secret.txt file. Inside this text file I have the data, that is hi, hello, how are you. This is a secret message. So I have this data stored inside this secret.txt file, and I want to transmit this data. So if I want to transmit this data, I have to make use of encoding operation. So I have to take one BMP image and I have to store this data, that is secret.txt file data, inside this BMP image. So encoding is nothing but hiding the data. So here we are hiding the data present inside the secret.txt file into this BMP image. After hiding the data of secret.txt file into the BMP image, the image we get is the stacked image. So this stacked image will have the data of secret.txt file. We are going to give this stacked image to the receiver, where the receiver performs the decoding operation. Once the receiver performs the decoding operation, the receiver should be able to get back the data, that is in fact the original data, that is secret.txt file data. The receiver should get back this data. So here what I am doing is I am taking one BMP image, I am storing the data of secret.txt file inside this BMP image. So after storing the data inside this BMP image, what image I'm going to get is the stacked image. I'm giving this stacked image to the receiver, and the receiver will perform the decoding operation, and after performing the decoding operation, the receiver will get back the original data. So this is encoding and decoding. So here I'm going to store the data inside this BMP image. So here I'm going to store the data inside the BMP image from the LSB, because I will explain you why the data is stored at the LSB. So let us consider two scenarios. This is scenario number 1 and this is scenario number 2. In scenario number 1, I have a number 00000000. So this is the data I have got. So I want to change the data. Suppose I want to change 0 to 1, so I'm going to change the data from the MSB. So suppose if I change 0 to 1, the difference between these two numbers is very huge, that is the difference is 128. So if I start to change the data from the MSB, the difference will be very huge. So this is the scenario number 1. In scenario number 2, I will change the number from the LSB. So see here, I have changed this 0 to 1. The difference between these two numbers is very small, that is it is only 1. So here there is a minute difference between these two numbers. So when I try to modify the number from the MSB, the difference will be very huge, and when I try to modify the number from the LSB, the difference will be very small. So that's why I'm going to store the data inside the BMP image from the LSB, because whenever any person looks at the BMP image, the person should not feel that some manipulation has been done for the image, that is the image should not look shabby for the person. So the person should not be able to recognize that some data has been hidden inside the BMP image. So that's why I'm going to store the data at the LSB of the BMP image. So now I will explain the structure of BMP image. I have one beautiful.bmp file and I have a stego image. So first we have 54 bytes for header. So in header we have 54 bytes. Then next we have RGB data, and at last we have end of file. We cannot modify header because it has properties of image, like size of image. If you change something in the header, it will change the image. In 54 byte we have to start the encoding. We have opened the stego image in W mode, that is write mode. If the file doesn't exist in the write mode, a new file will be created. By default it will be an empty file. Next we have to copy first 54 bytes from beautiful.bmp to stego image. Because we are creating new file, it should be exactly same as beautiful.bmp. RGB data can change because we are going to hide the data, but the header bytes should not be changed. We have to do this operation, that is, first we have to copy the header bytes to stego image before encoding the magic string. We have to next encode the magic string, because magic string is like a password. Suppose we are randomly sending 10 images. We have to pick the correct image from these 10 images. So it is not possible to pick the correct image. So for this purpose only we have to encode the magic string. For magic string we have hash star, so we are going to encode it. So this character should be known by both, that is the hash star should be known by both the encoder and the decoder. If you are the decoder, you should know that after 54 bytes of header, the encoder encoded the magic string. By using the magic string, the encoder can find the encoded file. Magic string is like a password. It should be known by both the encoder and the decoder. Next, we will encode the secret file. In encoding, we are passing .txt. In decoding, we will decode the image. We should store the image data in some file. For this, we have to create a text file. Encoder will know that .txt data is encoded into image, but the decoder will not know, so we should encode the secret file also. First, encode the secret file extension size and then encode the secret file extension. For example, if you have used the extension .txt, so there are 4 characters, so these 4 characters needs to be encoded. Extension size needs to be encoded. If it is .c, then 2 characters. If .sh, then 3 characters. Depending upon the extension, we have to encode. First encode the size of extension and then we can encode the extension. By using the extension, that is .txt or .sh or .c, decoder is going to create the output file. For that purpose only we are encoding the extension. Next, we are going to encode the secret data size. Then we are going to encode the secret data. After decoding the magic string, the extension of file can be anything like .txt or .sh or .c. If it is .txt, decoder have to decode 4 bytes of data. If the extension size is not there, then it will be very difficult for the decoder to decode it. If the size is 4, then the decoder will know he will have to decode 4 bytes of data. Same for data size. The data can be anything. You can store your name, number, etc. That's why we are sending the size also. So for this purpose we are encoding the size also. To encode one character, 1 byte, that is 1 byte of secret data, we require 8 bytes of image data. To encode hash, we require 8 bytes of image data. So to encode hash star, we require 16 bytes of image data. We are going to fetch 16 bytes from beautiful.bmp and encode hash star and write the data in the stego image. Next, we have to encode the size. Size is an integer. The integer is 4 bytes. We have 32 bits, so we require 32 bytes of image data. After 16 bytes, fetch 32 bytes from the beautiful.bmp. Then encode the size. For file extension, the number of bytes are not fixed. The file extension is user defined. Again, we have secret data size. Size is an integer data. Again, 32 bytes for secret data size is required. So 32 bytes of image data. For secret data, we have 25 characters. So total 200 bytes. This 200 bytes is not fixed. It is dependent on the secret data. So totally 366 bytes are used to complete the encoding. The total size of beautiful.bmp is 2.25 MB. In 2.25 MB, we have used only 366 bytes. Still RGB data is remaining. So if you do not copy the entire RGB data, or if you are missing any pixel, we will not be able to create exact image as beautiful.bmp. So next operation is to copy the remaining data from beautiful.bmp to stego. So our next operation is to copy the remaining data from beautiful.bmp to stego image. Then only we can create an image which is similar to beautiful.bmp. So this is the image which we have taken. In this image we are going to store the data. After storing the data, we are going to create a stego image. So these are the steps to create a stego image. That is, we are going to copy first 54 bytes of header, then we are going to from the RGB data we are going to take 16 bytes for magic string, then again 32 bytes of extension size, again 32 bytes for extension, then again 32 bytes for secret data, and next for 200 bytes for secret data, means whatever data is stored inside the .txt file, for that we are allocating 200 bytes from this RGB data. After allocating all this memory, that is 16 plus 32 plus 32 plus 32 plus 200, still some memory will be remaining, means still some RGB data will be remaining. So we have to copy that RGB data, that is copy remaining data. Then only we can create a stego image which is similar to beautiful.bmp. So this is how we are going to create a stego image from this beautiful.bmp. Then next is I will show how to perform encoding and decoding, that is how to execute our file. So we have, for encoding we have to give the option -e, and for decoding we have to give the option -d. So if we so -e is used to perform encoding and -d is used to perform decoding. If you do not give any option, that is if you do not give any -e or -d, then it is going to print an error message. So if you want to perform encoding, we have to give ./a.out followed by the -e, then we have to give the file name, that is beautiful.bmp, and then we have to give the secret.txt. So this is the text file which we want to encode it into an image, that is into a .bmp image. So this data we are going to encode it into beautiful.bmp. After encoding this beautiful.bmp, that is after encoding the data into this beautiful.bmp, we are going to create a stego image. So if you want to decode that stego image, we have to give the option -d, that is ./a.out followed by -d and the stego image.bmp. Then we can perform the decoding operation. So like this we have to give the file names, then only we can perform the corresponding encoding and decoding. The next I will explain the flow of how to perform encoding and decoding. First we have to read and validate the encoding arguments. Then we have to do the, if it is encoding, that is if it is -e, then we have to go for encoding. So here the user can enter -e or -d. So first we have to check whether the user has entered -e or -d. If the user has entered -e, then perform encoding. So first we will see encoding. So when the user has entered -e, then open the files, open beautiful.bmp, secret.txt in the read mode and open stego underscore image in write mode. Then next is to check the capacity of the BMP file. If the beautiful.bmp is of 2.5 MB, we cannot store 5 MB of data inside it. So for that purpose we have to check the capacity. Then next is we have to copy the BMP header. Then we have to encode the magic string, that is hash star. In our case, magic string is nothing but hash star. These are random 2 characters. These are treated as a password. Then next is we have to encode the secret file extension size. So whether it is 4 or 2 or 3, like we can give .txt or .c or .sh. So in similarly we have to encode the secret file extension. So whether it is .txt or .c or .sh. Then next we have to encode the secret data size. Then next we have to encode the secret data. Then next we have to copy the remaining data. So this is how we have to perform the encoding operation. Then next is decoding. So if the user has entered -d, then we have to perform the decoding operation. Then next we have to open and validate, that is whether the user has passed -d option or not. Then we have to open the files. Here we have to open only stego image. Then we have to skip 54 bytes of header. Then we have to decode the magic string, that is hash star. Then we have to decode the extension size, that is 4 in our case. Then we have to decode the extension, that is .txt. Then next we have to create an output file with the decoded extension, that is we have to create an output file with .txt extension. Then next we have to decode the secret file size. Then next we have to decode the secret file data, store the decoded data to the output file. So this is about the decoding. Now I will show the demo of the project, like how to execute the project. So here I have beautiful.bmp file. These are the header files, that is common.h, decode.h, encode.h, types.h. These are the header files. I have decode.c and encode.c to perform the encoding operation or decoding operation. Here I have test underscore encode.c. So this that is the .c file is used to check whether the user has passed -e or -d. So based on the option entered by the user, the corresponding encoding or decoding operation will be performed. So this is the secret.txt file. The data present in this file should be encoded in this beautiful.bmp. So my objective is to encode the data which is present in the secret.txt into a beautiful.bmp. So when I encode the data present in the secret.txt into this beautiful.bmp, a new file, that is a stego.bmp file will be created. I will show you. So I will show you the data present inside the secret.txt. So this is the data present inside the secret.txt, that is my password is secret. So I will execute and show you the project. So first I have to open in terminal and I have to compile all the files. So I have to give gcc start.c. So when I give this, all the files will be compiled and one executable file, that is a.out file, will be created. So when I give /a.out, it will show me the options like -e and -d. So if you want to perform encoding, you have to press -e. If you want to perform decoding, you have to press -d. So now first we will see how to perform encoding. So to perform encoding, I have to give /a.out followed by -e and the name of a BMP image, that is beautiful.bmp, and the data which you want to encode, means the name of the file whose data you want to encode. So we want to encode the data present inside secret.txt. So I have to give the file name secret.txt. So if you want to create a stego image by my name, so I can give nikhat.bmp. So a stego image with the name nikhat.bmp will be created. So I will show you. See here. So here you can see a stego image by my name. By my name has been created. So nikhat.bmp. So an image by the name nikhat.bmp has been created. So this image will contain the data which is present inside the secret.txt. So see here, opening required files, open beautiful.bmp, open secret.bmp, encoding procedure has been started. Like here we are going to copy the image header, we are going to encode the magic string, again secret file extension size, secret file extension, secret file size, secret file data, and copying the leftover data. So like this we are going to perform the encoding operation. Suppose if you do not give this name, that is nicker.bmp, if you do not give this nicker.bmp, so a default file by the name stego image will be created. I will show you. So see here, stegd underscore image.bmp has been created. So this file has been created by default. So if you do not give the name, so by default this image will be created. So here also we can see that encoding procedure has been started. Again checking for secret file size, copying the header, copying encoding the magic string, encoding the secret file extension size. So this all procedure has been started. So again here we are performing the encoding operation. So if you want to perform the decoding operation, we can give ./a.out followed by -d and the name of the image which you have created. That is, I have created nicker.bmp, so I'm going to give nicker.bmp. So see here, it will show decoding procedures are started. Open required files, open nicker.bmp, open decoded.txt. So decoding done successfully. So like this we are going to perform the decoding operation. So if you want to decode the file, that is the default file which has been created. So the default file has been created by the name stegd underscore image. So if you want to decode this file, I can give ./a.out followed by -d and the name of the file, that is stegd underscore ing.bmp. So here I can see, so when I give this file will be decoded. See here, decoding procedure started. Opening required files, open stegd underscore ing.bmp, decoding magic string signature, decoding output file extension, output file not mentioned, creating decoded.txt as default. So a default file, that is decoded.txt. So this is about decoding, like how we have to perform the decoding operation. So if you want to view the decoded text, so this decoded text will be stored in a default file, that is decoded.txt. So we will see how the text has been decoded. So my file was secret.txt. So we will view what is present in secret.txt with the help of the command cat. So see so inside secret.txt I have my password is secret. So we will see the decoded.txt file. So here I should get the same, that is my password is secret. So here also I have to get the same data. So see here, so here I have got the same data, that is my password is secret. So like this we can encode and decode the data. So this was about encoding and decoding. Thank you.